Alright, today in this video we're going to go over what it means for a number to be rational versus what it means for a number to be irrational. Most of your numbers that you've been working with are going to be rational numbers, except for square roots. Now that we've introduced square roots to your knowledge, you can now classify numbers as rational or irrational numbers. There's also a couple other examples that you've used previously in life that are irrational numbers, and I'll give examples of those in this video. So let's go over rational numbers first. Rational numbers can be whole numbers, integers, fractions, decimals that end, decimals that repeat, and I'm going to put one more on this list, but it technically is a whole number, but the square root of a perfect square well, that is a whole number. So it will be rational, but sometimes it's nice to have that on this list just to remind ourselves, like if we take the square root of a perfect square, it should be a whole number. And if you're not getting a whole number, then it's not a perfect square. All right, let's go over an example for an irrational number. Irrational numbers are numbers that go on forever, do not end, or do not terminate. These are just three different ways to say the exact same thing. So for instance, if you take the square root of 2, well, that would be 1.4142135 ... and we could just keep on going forever. So the square root of 2 would be an irrational number because when you evaluate it on a calculator, your decimal is never going to end. Okay, so again, these are three different ways to say the exact same thing, right? So for instance, the most famous example of an irrational number that you've used previously in your life is pi. Pi is an irrational number because it's 3.14159 and very famously goes on forever and does not end. Okay, another one that you might not have heard of is e, and e also goes on forever. And so E is 2.7182818285 ... just keeps on going forever. Okay, and so those are all examples of irrational numbers. Let's go over all of our examples for rational numbers. A whole number, well, that's like 1, 5, 7, 4, right? The numbers that we've worked with most of our lives are whole numbers. Integers, though, were introduced to your vocabulary in middle school, and those are all of your negative numbers, which would also fit in with your whole numbers. So integers encompasses whole numbers and negatives. So you could have like -5, -11, but this also encompasses like 2 and 6. Just like your whole numbers. Fractions, right, are when you're dividing one number by another number. And so all your fractions, if it can be written as a fraction, are going to be rational numbers. So for instance, like 1/7, 2/9, even a negative like 1/10, those can all be written as decimals that end or decimals that repeat, which means that they're rational because when we actually divide them, we're going to get a decimal that ends or decimal that repeats. Okay, so for instance, decimals that end, that's going to be like 7.25. Like very literally, there's no number after this 5, which means the decimal ends. And decimals that repeat, that's like your 0.3 repeating or your 0.6 repeating, right? And so the 0.3 is 1/3 and the 0.6 is 2/3. Some pretty popular fractions that you work with. And so those are those repeating decimals, which means they are also rational. So these three rationals kind of go hand in hand: the fraction, the decimals that end, and the decimals that repeat. hopefully this video kind of clarified for you like how to classify a number as rational versus irrational.